Merlin, network magic, introducing infrastructure as search. Hey everybody, my name is John Capobianco. I'm a senior IT planner and integrator with the Canadian House of Commons, the Parliament of Canada. I'm a two-time CCNP. I'm a Microsoft certified IT professional enterprise administrator, five-time Cisco certified specialist, 20 years in the field. In case this is your first video or an introduction to who I am. More recently, or more importantly, I've launched an open source project called Merlin, Network Magic, that's built on the PyATS framework and PyATS libraries, as well as things like Python requests and different Python libraries to connect our infrastructure as code to now be infrastructure as search. And they're very closely related, infrastructure as code, and what I'm terming or calling or coining the phrase infrastructure as search. Because we can use infrastructure as code to go get our state of the network or RESTful API information in JSON, and then we can index it and ingest it into ElasticSearch and the ELK stack. So I've done a lot of refinements and I figured this out and put together a few videos so far that have been my development progress. And this one is actually infrastructure as search. I've done it at scale. We're going to do one together. So let's just take a look at this together and we'll start slowly. So what I'm going to do is putty into the DevNet sandbox to show you the old way. So I'm on the sandbox, and what we're going to do is add one new command to an index and ingest the JSON into that index, and then we'll add a timestamp to that data as it's ingested. That's our goal here, is to take the following command, show vrf all interface, and this is what we would normally get at the CLI. Is this table that lists our interfaces, be it a VLAN, a loopback, a physical interface, or the management interface, and we can see that they're all in the default VRF except for the management. Now, that's the old way, is to come into the CLI and run the command. Now let's do this with PyATS. All right, so what you can see is I have a bunch of learned features. So we learn a certain feature and we get the JavaScript object notation back. And then in the second half, I've been working through the show commands. And I'll show you why I'm able to do this so rapidly is because someone from the community helped me write a function here that I just feed in, and I'll put them side by side here. Right? So I have a parse show command function and a parse learn function. So everything here goes through the parse learn function, where we say device.learn, the PyATS library, and then the function name we pass in, ACL, RBGP, etc. But we have the parse show command where we say device.parse from the library, and we feed in the appropriate command. So let's go ahead and do the new command together. That's not a part of the index. This is live development. So we take this here, and we just paste it in here, and this is all, interface. Interface here, and I'm going to change that to interface and that to interface. So as of line 146, inside of self.parseShowVRF all interface is the results of the JSON representation of what we just saw on the CLI. This in JSON. That is what effectively is in line 146 inside of this variable. So now we're going to go to the bottom here and we're going to do the same copy paste, and I'll talk over what we're doing here. So I'm going to paste in this function. I'm going to take out the print from there because I know that one works. And instead of show vrf all detail, we're going to find detail and replace it with interface. And then we'll go through this one by one. So that's the comment. And now I'm saying if it's not none, Okay, so if it's not none, then proceed and template, right? Go set up a variable that has the template and then render the template passing in the full set of show VRF details. So let's go ahead and replace detail here and here and here. And now I like to print it in case it doesn't index. For some reason, there's an illegal character, for example. So I'm going to print it on my first run. And then I'm going to, oh, and I need to change that. No, to show all VRF interface good. Detail here in the next comment. Now here is where we're actually indexing it, ElasticSearch.index. And ElasticSearch is defined at the top with my cloud ID and my credentials. So ES equals ElasticSearch and then my cloud ID and my auth. All right, so ES dot index. Go ahead and index. And what are we indexing? Well, where are we indexing it? We're going to index it into the device alias in lowercase, underscore, and then the name, and this still says detail, so let's replace that, interface. All right, so that is our index name. And then we're going to give it an ID of a unique ID. And again, at the top here, I generate a UUID in Python. A little bit higher, right here, unique ID equals UUID 4 in hex. So there's no illegal characters, it's just a hex string that I make the ID. So index it into a table, or an index, I should say, excuse me, index this, and then give this particular stamp of JavaScript, the body we're posting, a unique identifier. So that every data set is just randomly generating a UUID, and we can call any point in time of the timestamp. Now, again, what am I posting as the body? Well, I'm posting the raw JavaScript object notation that I've passed through this Jinja 2 template called ElasticStandards. And ElasticStandards, and I want to point something out, I'll come back to this. The first thing I'm doing is lowercase. Well, what I've learned over time is that I can do this here in Jinja 2, which is client-side processing. Well, I could move this lower to the pipeline that the indexing runs through as it's ingested into Elastic. But for now, I'm going to leave it here, and I just do a bunch of regexing to get rid of illegal characters and to make it valid JavaScript object notation. Okay, so I should be able to save this. And now the first thing I have to do before I run it is I talked about the pipeline. So I'm just going to copy this, the index value, and I'm going to move into Postman real quick. Now this I've already done, but I want to show you when we talk about the cloud-side pipeline, you need to go into your cloud instance, right, which comes from your Elastic dashboard here. You copy this endpoint to get your ElasticSearch URL. And then we need to go underscore ingest. So as we're ingesting, I want to set up a pipeline called Merlin pipeline. And it's going to have a description that just says timestamp. And here's the key is the processors. And here I could run it through a lowercase processor and remove it from the Jinja 2. But what I'm doing is I'm setting a field called underscore source ingest time. And the value is the server side ingest timestamp, and you can see this is a variable. So I've already set up this pipeline, but now I need to tell my new index, and I'm going to go here, right, after my host name, the variableized device alias, underscore show VRF all interface. So this is an index where I'm going to be ingesting the JSON. Well, I want to say settings, the index's default pipeline is Merlin's pipeline. And we post this, or put this, excuse me, and we get it's true, and here is the index. Now, can I confirm the index? Certainly can. If I go into my API console here and paste in that new index, we can see that it has a default pipeline of Merlin pipeline. When it was created, the number of shards. So now this is where I'm going to be ingesting that Python that we just set up here. So let's run the code. And now what I've done is nothing is commented out. So we're going to get this full set of data. And let's just quickly go over it again. Right, so we're learning access control lists, address resolution protocol, border gateway protocol, interface, open shortest path forwarding protocol, platform, routing, VLANs, virtual route forwarders. This is everything we're learning. And then we're running some specific commands, some surgical commands, such as show BGP process VRF all. Give me every BGP process on this device. I'd like to index it so I can search for it. The BGP sessions, interface status, inventory, IP interface brief, IP OSPF, IP route, MAC address table, port channel summary, version, VLAN, VRF, VRF all detail, VRF all interface. Deep breath. And again, I want to highlight that is only a subsection of what's available. If we go into the main Merlin, on a real environment, look at all of the stuff we can learn. The config, the HSRP. Look at all the show commands that we can run, even more in a real world. I'm limited to the sandbox's virtual environment. So let's go ahead and run the code. All of this stuff is going to be indexed into its own table and timestamped by the pipeline server side. Okay, so before we run the command, and I'm going to run it with the time command, and I'm actually going to inspect the time this time. I'm going to really try to remember to do that. I tend to just jump ahead. But also, in this output at the end, we should get a log with the status code, meaning the REST API's response code to our put. So we're going to do a put into an index with a UUID per learned function and per show command. To give you a sense, again, this is what we're doing is an ingestion pipeline or an ingest pipeline where, as opposed to documents, and think of that, think of our JavaScript object notation from learned BGP or show IP interface brief. That is the incoming document. And this is a document database, a NoSQL database, a horizontal database. Lots of ways to look at it. Now in our ingest pipeline, again, I have the lowercase client side in the Jinja 2. That could be inside of the pipeline. Here in our pipeline, we are ingesting the timestamp into our target index. I have a bunch of other stuff open that we'll come back to, but let's run the code. All right. And there's one step that we're going to do in Kibana. Once this is indexed, we're going to create an index pattern. And then we're going to come back and just so that I don't forget, I'm going to create the index pattern. And then we'll come back and we'll look at the output. Now, right now, what's happening in Merlin and what you see is it's learning the different functions. I think it's on ACL or Learn BGP. It's probably on BGP now. And then it's going to learn and learn and learn. Eventually, we'll see more ASCII kind of as a delimiter, as a placeholder for us to know it's moved on to the show commands that it's going to parse. But right now, we're still learning, and that's okay. And remember, I'm over a 5 megabit DSL. It's very, very poor, the worst internet in the world right now, aside from dial-up. So now there's the ASCII, and we've moved into the show commands. So these are the different show commands that we've chosen to parse and to index. Now, here comes all of our API calls. And the green, so we see this is great news. Everything has passed. We have our learn steps, our parsed show commands, and then our post it all to Elastic. Now I want to highlight the command that we've been working on that we've added is this index, the devnet show VRF all interface. Here is the UUID that was generated. We have a status 201, but everything here, because I've chosen to print it to the screen, is the JavaScript object notation that we've just put into this URL. Now let me go ahead and add it to, and this is a good validation step for me. If I jump into my deployments, and well, let me just go the long way since I opened this. Deployments into Merlin, launch Kibana, and what I want to do is add that as an index pattern for Elastic to work with. So from this main homepage in Elastic, I'm going to go into the hamburger, and then I'm going to pick Stack Management. And at the bottom here, I have my index patterns. And this is pretty neat. So let me get into the index patterns. And here you can see are my index patterns. And I'm going to change this to 50 rows. So I have an index pattern for all of those indexes that we've posted. Let's create the index pattern for the VRF interface. So I'm just going to say dev, and it's going to be the last one alphabetically. So we're going to take this, and we're going to index it, or create a pattern out of that index. Now it picked up that I have a time field, which is the ingestion time, which was part of the pipeline as it came in, as it was ingested. That is not part of my local Python at all, or my Jinja 2 template or anything. That was cloud side as part of the Python. So I'm going to create this index pattern. And that's it for now. Now look at this index pattern. It has 361 fields. And let's look for the ingest. There's the ingest time, and you can see that it's a date field. It's searchable and aggregatable, right? There's no scripted fields, no filter fields. But we can say, okay, show me all of the date. There's just the ingest time, the long. Well, the VRF IDs are all long. The keywords, there's all these keywords. Text, all of the text fields. So now it is part of my index patterns that I can then use to visualize the data. Now let's go back to our job. Now we truly have a public API on the internet, available publicly. If you had the username and password, you could type in this URL and get that set of data. So let's go explore this. And there's many places and many ways we can look at this. So I'm just going to take it into Postman for now. And I'm going to make a new, right, I'm going to duplicate this and call this get, and this one is VRF all interface. And I'm going to paste in that URL and send it as a get. So here is the data that we used to have as a show command on the CLI, right? And I can work with this data using ElasticSearch, its own domain-specific language. Now I have a bunch of things I'm going to show you here, but let's just take a deep breath. I'm going to save this. And now I can look at the structure. Remember the types of data? Well, for this particular index, and all I'm looking at here is the index, I have all of the properties of these key fields, meaning I have the schema that I could send to developers to develop solutions, applications, front ends, queries, all kinds of different things. Now, if I put in _search here, you can see that it is a search. And I have hits, and I have the index. And if I keep scrolling here, maybe I can collapse it here in Postman. Maybe not. Yes, if I collapse these different, so there's two of them, you can see that those are my different UUIDs. There's one UUID, and there is the other UUID. So I have all of the historical stuff that I can then search with a search language. So let me try to do this and not screw this up. I believe if I just say question mark, and you can see in Postman I can say the key here. Well, what if I say source And then I'm going to add another key of loopback, and then send it. No, illegal request. Loopback 1. Let me get rid of loopback. Source. I think I have a pre-canned example here. Yeah, equals loopback 1. Let me just steal this. I'm not perfect at this. I'm still learning. If I do it like that, no. Parameter loopback 1. Interface. Oh, I'm in interface brief here. I want to be in VRF interface. I'm sorry. So here, if I do a search, and you can see here source and the value of the source is loopback 1, all I get back is loopback 1's history throughout my indexes. So if I continuously run this, I can see that maybe the VRF has changed on loopback 1 and when it changed in terms of, right, I could go find this ID then, and I believe I say, let me try this, doc, and then that ID. I get the full state, which has then the ingest time, and I know that as of that time, I can follow the cookie crumbs as to when that value changed from default to some other VRF. That's an on-the-fly example, right? So again, let me just do interface all search source, and we have all the hits. And then we can also just do search. And this works on any of the, here's learned platform and a specific instance of learned platform, that one document. I can change this to be underscore search, and now I have the platform hits throughout history, and I can just continue to build onto the keyword search here. So if I do, what's my sources here? And again, I'm not sure if I can dot into all of this. We can try that together. Source equals underscore source equals, where are my headers here? And the key is, let's say, virtual device. Now, can I do dot one dot membership dot eth13 to say find a specific? Yes, I can. And now, well, it doesn't. It gives me the whole body. It's too bad. I was wondering if I would just get this membership. Lots to learn here, lots to play with. Now, let me go to the documentation. Or also, I wanted to show you that those same things that I'm doing there work here in the API console. So again, here's that search question mark source equals loopback 1 in the VRF all. And right here in the API console, it gives me the same information here. So let me show you a bit of documentation. Right, they have the search API, and we do our target search, or we can even post a search with different bodies. And here, look at all of these parameters. I'm not going to go through all of them, but I want to get you a sense of how rich the environment is that we can build Google-like search engines through APIs, right to our indexes. All kinds of great stuff. And then the response body that we get back, and they have some examples here. Right, so we can do a query of a term against an index, and maybe we could look for things like interface status, or opper status is up or down, or right, and do different searches, and then we would get the different bodies of data back. Now they also have queries, string queries, where we can do query like New York City and Big Apple. Right, we could do interface a certain loopback or management 0, or I don't know, input rate or output rate, and so then again, massive, huge amounts of options and wildcards, field names, right, where status is active, where the title is Quick or Brown, where the author is John Smith, first name Alice, lots and lots of stuff. Wildcards here, regular expressions, fuzziness, ranges, everything, Boolean operators, grouping, reserved characters. It's just an infinite just an incredible set of tools for us as developers. I also want to highlight this. This is one of those URLs. You can see there's my Merlin and my DevNet Sandbox VRF, and here I have the search question mark sources loopback 1, and there I get just that limited information. So again, I wonder if it's cached my credentials right here in the browser. Yeah, forget Postman or anything else. It's the data is available in the cloud in a searchable index per set of data. Now, where I'm going to go next, I'm just going to pause the video here to break it up a little bit. I'm going to be in Kibana next, making dashboards from these index patterns. And now that I have all these index patterns, I can choose from different fields to make different visualizations. So here's my plan, and let me just move back to chatting screen for a second. What I plan to do next is build a few different dashboards. I have found management and loopback and ETH15. There's a few different interfaces that I can run a continuous ping through, stop the ping, ping again, right? And what I plan to do is do this on a few different interfaces. Have the Merlin run for, say, 15 minutes continuously or 20 minutes continuously. Let the pings run, stop the pings, ping again, and then see if I can make a living dashboard that we can explore through that time scale of the 15 or 20 minutes that I run the Merlin. Now, speaking of time, and I totally forgot, I always say I'll do it. I put the time command on. Let's see how long all of this took. Right, less than 2 seconds of CPU time. Took about 1 minute and 7 seconds or 3 seconds of user time. You know, the real time, 1 minute 7, that's with all of the logs in the ASCII, but think of the CPU time. In less than 2 seconds, we've, in less than 2 seconds, we've gone and learned all those things, ran all those show commands, turned it all into JavaScript object notation, timestamped all of it, and indexed all of it in the cloud. I know it's a lot to take in, and I'm still learning, and I'm open to learning with you, but it really is incredible in my mind. That's why the whole network magic thing. And wait till I show you these dashboards that I get running. So I'm going to pause it here and collect yourselves and get ready for the dashboards visualizing now that we've indexed all of the data. Thanks and stay tuned. All right, so I've had a chance to build a few dashboards and to set up not infinite, but the 15-minute loop. And I've had some pretty good success. So I actually have a couple other things I have ready to go. So let me show you here. So where we are now is in Kibana. And we've already added our data and ingested our data from our network. And we've already created our index patterns. So from those index patterns, we can go into Kibana, and there's lots we can do with it. But for now, let's go into dashboards. And I have my dashboard for this device. And, it takes me right into it. That's fine. So here's the dashboards that I've managed to set up, and I've given them all titles, and they're pretty self-explanatory. And I can go into full screen here and see that I have management zeros IO, so the input-output rate, and the date and time, and it gives me all of the different input-output rates. And there's some lags from when I've been running the code and not. There's a little bit of a spike from my latest input now. Over here I have management 0 and Ethernet 1.5 side by side, and we can see there's no input-output on 1.5 yet. And as we go through, we can see the traffic collapse. Now this is a line graph with connected dots, and this is a horizontal or a vertical bar graph, excuse me. And we have our index, and we can minimize and get rid of, anything we want here. Same here, if we want to isolate it to just one rate or the other, we can. Now down here is just Ethernet 1.5, and this is a stacked or an area view. So you can see the area graph and all of the different keys that we have. And we can see that it's mostly output octets, total packets, and output multicast. Now over here I have just the percentage without a time scale, just the percentage scale. So on ETH15 at this point in time, everything is output packets. Now, exit full screen, and we go in here and we can say, if we go into edit mode, we can create a visualization. Now here, I have just the learned interface, but we can pick from all of our indices here, and then we have them available, the horizontal axis if we want time, because we've ingested time. I'm just trying to see if there's anything that might have numbers on it, or what we might want to visualize on here. But you get the idea. All of our indexes are available, and then we have all of the different fields per index that we can add as a vertical axis, and the horizontal axis we can have our date histogram, which is the ingest time. Okay, so let's go back and cancel, and let's just look at this dashboard and get it back into view. Well, I don't know about view mode, if it's live or not. If I just hit refresh, I'm going to leave it like that and let the time climb. So now what I'm going to do, on the device, I'm going to run an infinite ping, an unlimited ping, from management 0 to management 0's default gateway. So ping 1010 2254 from 2258. And then over here, I'm going to ping the loopback interface 01 from Ethernet 1.5. So let's kick off the unlimited pings. And then now, we're going to just continuously run Merlin in the background. Now this can be done, much more elegantly than me watching this and running it manually over and over again, right? We can run this through Espresso as a container or as a cloud function, or there's many, many ways, even as a cron job or as a scheduled task since it's Python. But for now, I'm just going to run this a few times, and then we're going to refresh the dashboard and hop back in, and hopefully some of the numbers have jumped up. Again, we have the unlimited pings running here, and hopefully that should bounce some counter information up and down. And we'll just run this again, and then we'll go check our dashboards. So here comes all of the posts, and we'll run this one more time, just get it running in the background. And let's go check our dashboards and refresh them here. And do we have any new numbers? Well, it looks like we have some numbers. Management 0 is climbing over the past couple of minutes here. We can see that it's spiking. And then over here, yeah, ETH1 input output isn't climbing, but management 0 is climbing. And this is all based on ETH1.5. And it doesn't look like it's picked up any new data. But you get the idea. We can build these dashboards from the data that we're feeding it from our indexes, which are constantly being refreshed automatically through automation like PyETS or Ansible or something. So that kind of wraps up where I'm at with the whole ELK stack and infrastructure as search. And I think it's a very exciting opportunity for solution developers to go beyond worrying about just configurations and SNMP and syslogs. Can we actually go get the state of the network and present it? And as a mentor of mine, Jeremy Schulman from the Major League Baseball, says, can we democratize this network state information that can make a lot more sense without having to worry about it's show this and show that and this interface? Can we make some nice graphs and visualizations and just make this data available to the people that care about their services? So thank you for joining me. I'm going to try to get this video up as soon as I can. And let's keep moving into the exciting world of infrastructure search and REST APIs and infrastructure as code and network automation. Thanks for tuning in. Stay safe.